All right, so implicit differentiation. So we're going to take a derivative, and it's not always about x. So we're going to actually derive things in terms of other things. So it's kind of like doing a derivative for x and y together. So that's basically what we're doing for this. That's eventually going to come up to our chapter 4 where we're doing related rates. We're doing all our derivatives, so you have a bunch of different variables in terms of time. So everything's going to be in terms of time because it's going to be like miles per hour or feet per second, meters per second, whatever, or flushes per, gallons per flush or something like that. So whatever the rate is that it's going. All right, so find dy dx if x, y minus 4 equals 0. So we're going to use implicit differentiation. So in between this and this, so we actually have two things here, right? So we have an x and a y. So what's happening between those x and y? Huh? You don't know? Multiplication. Thank you. That's what we're looking for. Multiplication, right? So multiplication is happening in between those two items. So we're going to take those and break it up. So xy minus 4 equals 0. So x, y minus 4 equals 0. So this is implicit differentiation. So now it's going to be a product rule. So if this is f and this is g, f prime would be 1. G prime would be 1, but we're taking the derivative in terms of something that's not x, right? So yes. So we need to actually state we're taking the derivative of something that's not x. So we're going to call it 1 times dy, because they took the derivative of y in terms of x. Dy dx. So this means that we took the derivative of y. If there was like a z there, it would be dz dx. Does that make sense? Maybe? Okay. So it's something new here. So now product rule says f prime g. So it's going to be 1 times y plus g prime, which is going to be 1 times this, which is just dy dx times f, which is just x. Now, so that's just this piece right here. What's the derivative of minus 4? 0. So that's, 0 equals 0, right? Or plus 0 minus 0. Either way, the 4 goes away. And so now I'm left with this right here. So now I want to try and get dy dx by itself. So I'm going to use a little bit of algebra to isolate this thing. So what would I do to actually get this piece, this right here, over here? So I'm just going to subtract because I'm trying to get the dy dx by itself. If I was having to divide it or multiply it over here on this side to undo it, I would have to do the opposite. So it would be either a multiplication or division. Since right here it's just adding to my dy dx, I'm going to have to subtract it. So 1 times y is just y. So I'm just going to subtract a y here and minus y here. So I'm going to get dy dx. So it's going to be x. I'm going to put the x, this x right here in front, equals negative y. Okay, so what's happening in between the x here and the dy dx? Multiplication. How do I undo that multiplication?
Division.
Yeah, let's divide both sides by x. So I get dy dx is equal to negative y over x. So that's taking the derivative using implicit differentiation. Slightly different, right? All right, so now I'm going to do it again But this time it said solve for y, then take the derivative. So it's xy minus 4, xy minus 4 equals 0. Okay, solve for y. So to get y by itself, on first do what? What would I do to that 4? Add 4. So plus 4 x y equals 4. How would I get that y by itself? I would divide, right?
Yeah.
Okay, divide by x. So y equals 4 over x, right? So yes. Okay, so now since that is it, so I'm going to go back here, okay? What would I do to the x to try and bring it up? If I want to bring the x up so I could take the derivative, what would it become? Negative 1, right? So y equals 4x to the negative 1, right? So now can I take the derivative? Okay, so it's going to be y equals negative 4, right? X to the negative 2. Okay, so let's go ahead and bring that back down. So y is equal to negative 4 over x squared. Okay, so let's take a look at this last one. Verify the results A and B are the same. Okay, so I have this right here, and I also had that dy dx is equal to negative y over x. All right, so because this would be a y prime right here. Yeah, I forgot to notate that one. So when I took the derivative, I had to change that to a y prime. All right, so I have dy dx is equal to negative y over x. Okay, so I gotta substitute now, don't I? Say yes. I have to substitute now. What am I gonna substitute? The y, right? So I'm going to substitute the y right here. So I'm going to take this, and I'm going to replace y in that. So I'm going to replace y there. So it's going to be dy dx is equal to negative, right? And so it's supposed to be the y value, which is going to be 4 over x divided by x, right? Yes? Did I lose anyone on this? Okay, because I just replaced that. So now, I have a fraction over fraction, don't I? Yeah. So I'm going to turn this to be over 1. So I cannot divide fractions. I always have to multiply by the reciprocal. So I'm going to flip over the bottom, right? So I'm going to get dy dx is equal to negative 4 over x times the reciprocal, which is 1 over x, which is going to give me dy dx is equal to negative 4 over x squared. Does that match over here now? Yes.
So why do we need the implicit differentiation if we can do the second one?
You cannot always isolate one of the variables. You can't. It's not always going to work out. Because if you start off with a problem that's like y squared plus xy plus 3 equals 0, can you get y by itself there? No. You can move this over, so it'd be y squared plus xy equals negative 3. You could try to factor out a y, but you're still going to have y quantity, y plus x equals -3. So you're not going to get the y by itself. Okay? Rarely are you going to be able to actually get the y by itself. So that's why you have to do implicit differentiation. And when you get into chapter 4, you're going to have like 3 or 4 different variables that you're going to have to account for. Okay? But when we get to that, you'll be like, oh, it's not that bad. Okay. Okay, so now, power rule. Okay, so whenever we're doing the power rule, we've done the power rule already, you know, for this, and so now it really doesn't matter if it's going to be the x, the y, or a z, or a theta, or some other variable that you're going to have to go along with it. Okay, here's an example of a y prime is the same as saying dy dx. You're taking the derivative of y in terms of x, that's the y prime. It means the same thing, just different notation. You're not supposed to see that one yet. Oh, there you go, okay. So if find dy dx if 3x squared plus 4y squared is equal to 2x. So we're going to take the derivative of every single part of this. So now, this says I'm taking the derivative in terms of x. That means that when I take the derivative of x, I don't have to put dx dx. Okay? I just take the derivative. That's what it is. Okay? But anything else that's not an x, it has to have a d something over dx. So, in this case right here, what would be the derivative of just this piece? 6x. 6x. Okay. Plus, what would be the derivative of just this piece?
8y dy over d.
Yes, 8y dy dx, right? Because in this function, I'm taking the derivative of everything in terms of x. That's why it's a dx right there. Equals. What's the derivative of this piece?
2.
Just 2. All right, so now, since dy dx is the exact same thing as saying y prime, I need to use some algebra to isolate that thing right there. So what would I do to that 6x?
Put it on the right.
Yeah, put it on the right? So I'm going to have to subtract it? Yeah, so I'm going to subtract it from both sides. So I'm going to get 8y dy dx is equal to 2 minus 6x. And to go ahead and get my dy dx by itself, so I'm going to divide both sides by 8y. So I'm going to get dy dx is equal to 2 minus 6x over 8y. And normally I would be done, but is there a common factor there that I could take out? I could reduce? Yeah, there's a 2 in all of it, right? So I could reduce everything by a factor of 2. So by doing that, that's just going to give me 1 minus 3x over 4y. Yes? No? Maybe?
Yes.
Possibly? Okay, good. Okay. Find an equation of a tangent line to the graph of the ellipse 3x squared plus 4y squared equals 2x at that point. Hey, didn't we already do the derivative of that? We did, didn't we? And my derivative of what? dy dx was? Very good. Okay. So now, it's asking for the slope at a point, right? Whenever I take the derivative, remember the derivative is always the slope. It's the slope of the line, right? The slope of the function. Yes?
Yes.
Okay. Now, what would I do to find the slope here? Plug in
1 over 2.
x and y, right? I'm going to plug in x and y because I have an x and y in my function. So it's going to be dy dx is equal to 1 minus 3 times 1/2 over 4 times negative 1/4. So let's see. On top, what am I going to get? Negative 3/2 plus 1. So it's negative 1/2. So I get negative 1/2 over negative 1. So I'm going to come up with just a positive 1/2, right? So two negatives make a positive. So now there's my slope, right? That's the slope of the line at that point. Now we're trying to find the equation of the tangent line. So to get the equation of the tangent line, I'm going to have y minus y1 equals m quantity x minus x1, right? That's the equation of a line. That's using point slope formula. My point is the x and y, which I have over here. So it's this x, this y, which is right there. And then m is going to be the slope that I just got from there. And so now we just go through and plug in. So it's going to be y minus negative 1/4 equals m, which is 1/2, quantity x minus 1/2. Let's see, so I'm going to have y plus 1/4 equals 1/2 x minus 1/4, and then I'm going to subtract a fourth from both sides, right? Subtract a fourth. So it's going to be y equals 1/2 x. So if I'm subtracting 1/4 from this, from both sides, right? So this would be a negative 2/4, wouldn't it? Yeah, which is negative half. Very good. Negative 1/2. So this right here is the equation of the tangent line to this point right, or to that equation. So it's basically some weird ellipse that looks like this. And at that point, which is the, so it should be over here somewhere. So it's going to look something like that. So the tangent line is always going to be a straight linear. It's always going to be linear. So out of this, because it's tangent, is going to be just touching at that one spot. So this is what you're always going to end up with, like a y equals something for the tangent, or the normal. Actually, I think that's where I leave off for today. No, I have to do this one here. All right, so find y if e to the y cosine x equals this. Okay, so I have, what did it say? It said e to the y cosine of x equals x plus 1?
Yeah.
Okay, very good. All right. So now, in this case right here, we're not going to be able to isolate the y. We might be able to, but it's going to be some issues. Okay, so what's happening in between the e and the cosine? Multiplication. So there's a product rule, right? So therefore, this would be my f, this is my g. So f prime would be e to the y. Nope.
Yes.
Nope.
We changed EY to the EY. Oh, wait. Just
Notice
EY.
that.
F prime is just EY.
No, it's not.
Notice on it.
EY, DY.
Thank you. dy dx. Thank you. You got it. So because it's a y, it's not the x, right? All right. So g prime would be, what's the derivative of cosine? negative sign. So negative sign of x, right? So product rule that side. So it's going to be f prime g. So it'd be e y dy dx times g, which is cosine x, plus e to the y times negative sine x equals 1, right? So the derivative of the whole right side is just going to be 1. Okay, so now let's go ahead and do some algebra, clean this up. So it's going to be, let me see, I'm going to bring this out front. So it's going to be cosine x times e y dy dx, right? So I just brought it out front. So I'm just changing right here. So it looks a little bit different. All right, and this is going to turn into minus e to the y sine of x equals 1. So now, what am I trying to isolate here? The dy dx, right? If I'm trying to isolate the dy dx, I need to get rid of the other stuff. So what am I going to do to the negative e to the y sine x? Add it. I'm going to add it, right? I'm going to add it to both sides. So I'm going to get cosine of x e to the y dy dx equals 1 plus e to the y times sine x. Now I'm trying to get the dy dx. So everything is multiplying by dy dx, right? So I just need to divide by all of it. So divide by all of it. So it's cosine x and e to the y so it's going to be dy dx is equal to 1 plus e to the y sine of x over cosine x times e to the y. So now that I have the derivative, here, let's go back to the question. Okay, find the derivative. Now find the equation of the tangent line to the graph at the point 0, 0. So now I have the thing, so it would be the point 0, 0. So let's see. I'm going to make a new page here. 0, 0, and my dy dx was, well,
plus e to the y sine x over cosine x.
Very good. Okay. So let's take a look. Now, unit circle time. Okay, this is the thing that's going to probably get us the most. Now, the sine of x. So x is going to be 0, right? X is 0, right? X is 0. So what's the sine at 0? This point right here is going to be 0, right? Okay. So what is the coordinate there? 1. It goes to the right 1. Does it go up and down? Say no. It goes is 0, right? So that means that the cosine, the x value, is 1, and sine, the y value, is 0. So now anything times 0 is 0. So this is just going to leave me 1 on top. Now, what is cosine at 0?
1.
It's 1, right? So it's going to be 1 times, now, right here, e to the y. What was the y value? What is the y value here again?
0.
The y value is 0, isn't it? Okay, so now the y value is going to be 0 here. So plugging in y is 0. So now e to the 0 is 1. Anything to the 0 power is always going to be 1. So it's going to be 1 times 1. So dy dx is equal to just 1, right? So my slope is going to be 1. So I'm trying to find an equation of this now. So now it's going to become y minus 0 equals 1 quantity x minus 0. So that's going to just give me y equals x. Y equals 1x. Okay? Let's see. I think that was it for this one. Yeah, because this one's coming up tomorrow. All right, so we will leave it off there. Don't forget, like and subscribe.